Hi, everybody. This is Mr. Youngren again, and we're going to continue our work with quadratics. And now that we've learned how to factor, and really not in this lesson, but we're going to start to put that to use here in the future. Before we do that, we're going to actually work with some of the graphing that we learned first semester. And so we're going to revisit how to graph quadratics. We're going to actually add some elements into those graphs just to kind of help us learn some different properties about the graphs of quadratic functions. Now, as always, we do have a warm-up where you're going to look to factor these. There aren't boxes on your page, but you can go ahead and draw them. So use one of our factoring methods that we talked about in our previous lessons to come up with the factored form of each quadratic or cubic for the opening problem. So go ahead and hit pause, work through these. I'll have the work ready to show you here in just a second. All right, here is the work for your opener. And this first opening problem is a very good example of why we keep pushing for you to look for a GCF right away. If I notice that both these terms share a common term of 9x, where its greatest common factor is 9x, once I pull that 9x out of both those terms, the quadratic's factored, and there's nothing left for us to do. And so the work here is so much shorter than what we had to do for the other ones. This is the only way to factor this, okay, is to find that GCF. Now, could you have had a box? Sure. Hey, we can still make a box here. It's just the problem is we only have two terms, and we don't need to find what multiplies to A times C and adds to B. It's really just a GCF problem. Now, the box does add some kind of organization to help you with that, and we can just a little bit easier to think about, okay, how do I need to get 9x squared? Well, definitely with an x and an x, but the only way to multiply to get 9 is going to be either with a 3 or a 9, and it honestly doesn't matter. So I went ahead and pulled out a 9x from both these terms. So I'm going to put a 9x here. So then 9x times x is 9x squared, and then 9x times negative 3 does give me negative 27x. So you don't need the box. It can help you if that's where you want to head towards when you first see this. But if we look for a GCF, that one's done very quickly. The second one, there is a GCF of 2. I did take that out. It's not that you need to do that, but it just makes the numbers easier to work with, because now, after I take out a 2, I'm trying to figure out what multiplies to 3 times negative 2, or negative 6, and what adds to negative 5, which would be negative 6 and positive 1. And then that allows me to find the outsides. And once I have the outsides, this factors to 2 times 3x plus 1, x minus 2. And our last one, again, I took out a GCF of 2. It's not that we need to, but I like working with the smaller numbers. So when I did that, I went ahead and took all my 4 terms, put the x cubed in the top left, the x squared in the top right, x in the bottom left, and number in the bottom right, and went ahead and worked the outsides so that everything multiplied to get the insides. And so then I finished with the factored form of my GCF of 2 times 4x squared minus 5 times 2x minus 5. All right, so like I said, we're going to be graphing. That's our next standard, is that I can graph a quadratic in vertex form. This is actually a standard back from first semester, but something that we're going to need in future lessons. So let's remind ourselves, how do we do this? Well, all of these quadratics are in our vertex form, right? If we see those parentheses, almost always that's going to denote that it's in vertex form, with some number being added after our squared. Now, when we're doing this, we want to start by finding the vertex. And our vertex comes from the x value that's in parentheses and the y value that comes after our parentheses, or after we square what's inside the parentheses. Now remember, with this, the x value, or what's in the parentheses, we always need to switch that sign when we're plotting the vertex. So the vertex, I see x minus 4, so I'm going to change that minus 4 to a positive 4. And the y-coordinate is what comes after, which is just 1. So now what I'm going to do is I'm going to plot 4 comma 1, which is right 4 and up 1. And then what we're going to do is use that a value to help us find our next set of points. Now there's a pattern for this. The pattern is that our first thing we want to do is take the a value, which is 2. That's going to be our rise, and we want to go over 1. So when we're doing this, A, 3A, and 5A, that's your rise. And we're going to always, always, always go over 1. There is not an exception for when you will not go over 1. So this is telling me, since the a value is 2, to go over 1 in both directions and up 2 from that previous point. The next thing that we wanted to do was to multiply that a value by 3. So 3 times 2 is 6. And this is my next rise. So this is telling me now if I go over 1 from those last points, now go up 6 from there. So I'm going to go right 1 and up 1, 2, 3, 4, 5, 6. And same thing on the other side, left 1 and up 6. And this is about all the points that we're going to fit. So let's go ahead and connect them, make that U shape. Also adding in the arrows, showing that the graph is moving all the way up and continuing on. Now, one thing that we're going to look to do is continue this pattern of using the a value in 3a, and the next step would actually be to take that a value and multiply it by 5, which would give me 10. Now, if that doesn't fit on the graph, we're not going to use it, but if we have an opportunity to fit more than this gives us 5 points to go through 3a, and we can get 7 points with 5a, we're going to go ahead and do that if we have the opportunity for it to fit on our graph. All right, so that's something we'll be doing throughout this lesson. All right, so let's do another one. And again, our x value for the vertex is inside the parentheses where the sign is opposite. So that x value is -6. And the y value comes after the squaring, so that is 4. I'm going to start there. I'm going to plot -6 and 1, 2, 3, 4. Now I'm going to use my a value by going down 1 and over 1 in both directions. Then I need to multiply the a value by 3. So -1 times 3 is -3, telling me to go down 3 and over 1 from those points. Down 3 and over 1. And this time, we're going to actually be able to fit 2 more points. So we're going to take it one step further and take that a value and multiply it by 5, which gives me -5, telling me to go down 5 and over 1 from that last point. So down 1, 2, 3, 4, and 5, over 1. Do the same thing on the other side. I'm going to connect my dots and add arrows at the end. And we have this very good looking parabola since we have 7 points, which is exactly what we needed. All right, let's flip this over to the next page. And I'm going to have you do 3 and 4 in class or on your own, but we're going to actually jump down to this next part. I lied. We're going to stop the video right there. So go ahead and hit pause or go ahead and close this. We are all done with the notes for today. You're going to complete the rest of this in class. So as always, make sure you do your video check-in and have a great rest of your day.